Scratch Asteroid walkthrough is now up, so you can download that. For anybody, Caden, just join in. Caden, if you would, go ahead and get logged in. Logged in. Turn on your Raspberry Pi. It sounded like most everybody had a pretty good lab yesterday. Good job. Most folks had theirs running. Well done. Raise your hand, Caden, once you have your Raspberry Pi set up, as well as Cooper, Jason, Keyshawn, or Ohm. If you're not going to have it at all, for whatever reason you don't have yours running, then raise your hand too, so we're not waiting for something that's never going to happen. For those of you who understand and want to go, leave your hands up, guys. Don't take your hands down. I'll take them down. Don't worry. I'll lower them in a second here. We're waiting. All right, good. So we got excellent. All right, hopefully everybody's got it set. Like I said, if you look under handouts, you're going to get the Asteroids walkthrough, and then this way you can go ahead and go about. If you want to go farther ahead, notice that'll be it. We'll get that started right now. All right, we got in a Space Invaders game, and we learned, and you did that in class, and we did that Monday, and you should be very proud of yourselves, how to physically tie it in to your hardware. As in engineering class, I think a lot of times people are surprised how much programming is involved in engineering. And even if you say to yourself, I like building and soldering, let me put everybody's hands on. This is a great question I'm going to ask you. Do you like, just think out loud, and then give me, raise your hand if you like building more than programming. Okay? All right, put your hand, all right. So we have a lot of our folks say, I like to build more, guys. Why are we programming, Mr. Dubik? Well, to do a modern engineering, you still have to do some programming involved with it. Better to get that, get good at it now, so when you get into engineering in college and high school, but maybe probably in college more, you'll get that fundamental in there. Also, programming helps you break down the problems on this stuff. Okay? So we're finishing up now, and if you join us in the spring, we're going to be building underwater robots in lab and doing things like that. But I just wanted to let you know that, so that way, engineering, you cannot do engineering with programming, and colleges expect you to have some programming behind you. So let me just say, at your high schools, when you go to high school, even if you say, I've done programming, I'm not crazy about it. But if you want to be an engineer, I can't stress it enough, take programming. Get it knocked out. That way it's not a big deal, and you'll see it's more and more useful. We don't just make machines anymore. We make intelligent machines. And honestly, we don't just even make intelligent machines. What I mean by that is they have sensors, they do things, they react to the environment. We all connect them to the internet now. It's the Internet of Things. IoT, you see it everywhere. So even if you think, I'm going to be building cars, I'm going to be designing airplanes, I'm going to work with Elon Musk, all incredible things, you still need to know some programming you're expected. And what you do in a programming, when you take a complex problem, break it down into pieces, that's what you really need to do with engineering. So I hope you can at least appreciate that. All right. So I'm putting everybody's hands down. Okay, now we're going to go on to this game. We're going to do another game, Scratch, this time for asteroids. And this time we're going to hook up our joystick and button to this. Okay? Many of you have your boxes. And I would love if you want to, if you're interested, send me a picture of your box and the way you did it. I would love to see it. Let me ask you this. Were your parents impressed? Were people impressed with your game console you built? Raise your hand if that's the case. All right, excellent. Excellent, excellent. I'm telling you, this is quite amazing for middle school age guys to be doing this. All right, and gals. All right. Let's go ahead, and this you're going to enjoy. Go play. I want you to go play Asteroids. This game actually is a little bit easier. And what's nice about this game is after the Pac-Man games are probably the most challenging one in the program, but the Asteroids is the easiest with the Space Invaders in between. The reason we start with Space Invaders, I want you to see what programs are available, and then as you look at this Asteroids game, you can immediately see things you might add to the game. So I'll tell you what, it's 8:10 now, well 7:10 your time, I'm sorry. Let's go play the Asteroids game if you haven't done it already, and just use the keystroke commands. Don't worry about using the joystick yet. Make sure your joystick's hooked up. I have a feeling most people's have it hooked up. How many people have their joystick hooked up to the Raspberry Pi? Raise your hand. Okay. If you don't, let's have it hooked up like we did yesterday, as you did for your deal, and or your lab, excuse me, deal. What kind of language is that? And it's 8:10 now. 8:15, play some asteroids right now. And then we can start looking at what's in the game, how we're going to make it, and then how you can change it and make that asteroids game your game. That's what we want. We want you to make that asteroids game your game. So it's 7:11 right now. 4 more minutes, 7:15. I'm going to interrupt it. And while you're doing that, I'm actually going to go over and check mine out. While I do that, I'm just going to flash through some code here right now. All right, go ahead. And we got a few more minutes. Go ahead and play it. Okay, let's take another minute or so. Give you a chance to go ahead and fire it. Maybe look at the code if you'd like. Okay. I think that's been about 5 minutes. All right. Okay, first things first, let's look at the ship. So I'm putting everybody's hands down. All right, everybody, let's look at the ship right now, okay? Unlike with space fighters, there's not nearly as many broadcast blocks to keep track of, okay? So if you know, win, collect, forever, switch to costume ship, so it might have been blown up, go to this location, here's your forward speed, the number of lives, score, and hits. And then we have repeat with our lives. Look at the left and right arrows and key space to hit down there more. So if you would, bring up your game right now and bring up your code on that game. So open up the game, stop playing it, bring it up so you can look at the code. All right. Now, hope you've seen that. So, we're keeping all of our code in a forever loop, so anytime our flag is clicked, your game is going to reinitialize. So whenever you click the green flag over there, it's all going to start over. All right? Now, one thing you might think about is this doesn't have a splash screen on it. So, you know, that's one thing off the hand that you might design your own splash screen. Make sure you give the person credit who designed the original one, but you can then make it, modify it yours. So, what I want you to know was, don't be afraid to use what's called that splash screen. All right. So you have your default costume, and we initialize things, which you all know. Initial position is 0, 0. Initial speed is 0. Lives 3. Score 0. Hit Boolean 0 or false or not hit. Okay. Then the code gives the ship some motion. Here's where we'll be adding our joysticks later. All right. So right here, you see that left arrow? That's where we're going to go to change our code to give the ship some motion, by the way. All right. This keeps going until we run out of lives, if you notice. This repeats until live equals 0, so that should give you a sense of this game. All right? We'll come back to that a little bit later. When the ship has not been hit, left arrow turns your ship 15 degrees counterclockwise. Right arrow, that's this down here, turns it 15 degrees clockwise. So pretty straightforward there. All right? The up arrow right here will let the ship move. The if statement that checks the forward speed will first increase the speed's variable, and after will decrease it. Your ship will start to slow down as the game goes on. All right, so you have your forward speed if you can find it on your code. Then this little bit of code says, hey, firing is a value and spacebar. It's going to hit something. All right. And again, this is where we're going to be adding our button, but we'll go in a little more detail of it. In this if statement, the game checks is the ship isn't already firing, so that's why it's got, hey, firing is 0. The ship hasn't been hit, 0. The space bar is pressed, and that's what we're going to change to be your button, right? That makes sense, doesn't it? Any questions so far? If all 3 conditions are true, the game will change the firing Boolean variable to true. All right. Identify the direction to shoot our laser and broadcast our laser that it needs to shoot. All right. So it's going to go ahead and say shoot. And then that's going to be a broadcast. And that's what that broadcast goes. And the laser is going to pick that up. Unlike in Space Invaders game, the forward speed is not defined by a wait time in between movements. Like you're not waiting, looping, waiting, and looping. It's defined by the amount of steps taken. So we did forward speed, and we were using how do I want to say? When it's received from the player. Let me show you what I mean. Instead, it's defined by the amount of steps it takes when an input is received from the player. So what it's doing is it's going to move forward speed, set the X and Y. It's waiting for the player to come back and give us that, okay? That may not be real clear until you play it. The game then stores the new coordinates in the variable ship in X, Y. It has that. Also, when it's moving, it's using the move command. It's not using set X and set Y, which is what we had in the other games, okay? It jumps back, waits a second, very short time you do, and it just jumps in, all right? And all it's doing is waiting to see if there's enough lives. If there's enough lives, it does it again. If there isn't, it comes out of the if-then statement in that loop, and it says game over, press enter, play again. If there are no lives, we get the game over message, which I just said. We also get a message telling us to hit enter to restart. Space Invaders did this differently. They broadcast back to one of the initialization broadcasts to restart. Is this necessarily bad? No. It's a different approach. Some people, this one goes directly back in. It doesn't really starts back up. All right? We tell it to hit restart. It just starts the game over again. Whereas, again, Space Invaders, if you go back and look at the code, I don't have a good way to pull up both those. We could look at it. It used broadcast messages to reinitialize it, if you remember. All we're trying to point here, I don't necessarily even care that you know the details quite so much on every line of code here, is that you see there's different approaches to playing this game. And this is where a lot of creativity can come in. Okay. And then the laser goes pew, pew. That's what you hear when you fire the laser. That's what that pew, pew. So, when I receive the shoot command, I'm the laser cannon. Point in the direction of shoot direction. Go to X ship and Y ship. Just basically like in our, when we did our own Space Invaders game, we told the laser to go wherever the ship is. Then we show it, because it's hidden. We play a sound, that's that pew pew sound. Repeat until it touches the edge. Move 10 steps. So it goes all the way up to the top of the screen until it hits the edge, then it'll stop. Then it says hide, sets firing to 0. So in other words, you can't, by setting firing to 0, it's not going to allow you, once you hit shoot, you set firing to 1. This sets it back to 0. So now you can shoot again. Otherwise, when this is running through this loop, you can't shoot a second time. All right? When you started the game, by the way, notice the green flag is there, that hit it. Our ship also set a variable called shot direction. Here we use this variable to direct our shot. The code also sets the initial laser position, same as the ship. You know why? Because you want the laser to come right up by the ship. Let me go back here. See if we can show this. Set shot direction to direction. See back here in this little bit of code, we had set firing to 1 to say, hey, you fired. You also set shot to direction. So we made that bit of code up here. Let me see if I can find the rest of the way up here. I gotta go to my code. So there it is, left arrow, left arrow. That's not gonna show me where I want. Okay. All right. It's not really giving me the direction command I can find easily to show you here. Okay. So we also use the laser. We'd probably like to see it, and then it plays the laser sound, and we just said that's what that purple does. We've not used sounds a lot, but there it is. All right. Any questions so far? I just went through a lot right there. Okay. All right, then let's go on. There's no questions. Our laser is going to move until it hits an edge, in which case it disappears. When we set our firing boolean back to 0, so our player can shoot again. We also set our laser to be initially hidden when a green flag is clicked. Okay? And again, you know, that's why we have that hide command. I just mentioned that a minute ago. Just like in Space Invaders, we have several asteroids, all with the same code. So go to any asteroid sprite and let's take a look. So someone, go ahead, take a minute here, click on your asteroid sprite. You can hear our 3D printer running in the background. Sorry, we have a lot of 3D printers. One of them's running right now. Okay? Raise your hand once you've gotten to an asteroid, please. I think you can honestly say, hey, Jason, Keyshawn, stay with us. This is probably our last night for programming this semester. Okay? So go ahead, pop a hand, please. Okay, great. Trey, let us know. Leave your hands up, Caden. Let's get to the part of this. Okay? Let's get to each one of the little rocks. Each one of the rocks. Each one of the asteroids. That's why they named it that. Okay. Just in Space Invaders, we have several invaders. I said that, so let's take a closer look. Nothing we haven't seen before. You got the big, this is stuff that you're used to. When clicked, you put everything in a forever loop. We're used to doing that a lot. And that's really different from maybe what your parents were used to when they learned some programming. Used to be you avoided forever loops. It was considered bad programming. You could never get out of the loop. Where in the embedded physical computing world, you're in loops all the time. All right? That's not unusual. Okay? All right. Remember, we switched the costume to asteroid. If you look back under costume on this, you're going to see there's a lot of pictures of different costumes on the asteroid, all right? The asteroid's movement is going to be randomized. That, again, we're not too surprised we do that. The variable called side will be set to a random number, and the asteroid's initial position will be set through the following if statements. So, if side is 1, it's facing the top. If the code receives a 1, the asteroid will start at the top of the screen. We'll set it to the top of the screen with a variable called start y. Right? Y, x is horizontal, y is vertical. The initial x position is also set randomly. It will start anywhere on the x-axis between -250 and 50. So right off the bat, we're randomizing. If it's there, we're going to pick up a spot for it. So do you understand? We want the asteroids to show up on the screen. We don't want them all stacked up. And you also don't want your players knowing where the asteroid is going to be every time, or they'll just start off and nailing this. If the code receives a 2, the asteroid will start at the bottom of the screen. Not surprising. Wow, y is a -250. All right? Or in this case, 200, excuse me. It will start at the bottom of the screen with a variable called start y. The initial x position, again, is randomly anywhere from -250 to 250. So x is either 200 if it's on the top, -200 if it's on the bottom. That whole goal is nothing but to get your asteroids to be different. If the code receives a 3, the asteroid will start at the left of the screen. We set it to the left of the screen with a variable called start x. And again, as you can see where we're going with this. This is the way of dropping in. And again, the initial position of y is also set randomly. It'll start anywhere from between -200 and 200. So when it's left or right, we're gonna move the start variable. We're going to change that start x variable. Just like a minute ago, we did the start y. See how we had to start y and we gave it to the top or bottom? So in the very first one, y was at 200. Then x was at random where it was. And then if it was side 2, we said y was -200. So it was going to be at the bottom of the screen. But again, x was random. In this case, we're going to do side 3 and 4. Start x, we're going to set a value for that. The farthest to the left is -250. Start 4 is 250 on there. Okay? Well, but notice now the y-axis should be random. And this really should be random down here. There's a mistake on my part. This should be random. That says start x. That should be start y. Okay? The asteroid will then move to this initial position. If it gets to set the point, move in a random direction. It then gets set to a point, moving around. The speed is also to a random number of steps. Okay? If you look at your code, you'll see that. Let me see if I can pull this. Let me back up here. see if I can pull that. Yeah, random number between 1 and 3. Point and direction is random, 30 to 60. Okay. Let me do one thing here since I did that. I want to back up since I caught that error. I want to make sure I catch it. This is really important. If you're making presentations and you see something you've done wrong, you need to make sure you catch it right then or you'll forget. Or I at least always do. Put text. Insert text box. Oh, here's this one. Thank you, monitor. You've worked fine for me all night, day, and now you're going to start acting up. Thanks. All right, we're going to make this bold. All right, there we go, bold. Okay. Should be Y, not X. All right, thanks, guys. Just better to have it right than wrong. Think about a teacher, if I tell you wrong, then I've told 21 people, not just myself, gotten it wrong. All right. Not that there's 21 people here right now, but I think you get the gist of it. Any teacher worries about that. All right. The asteroid will continue to move at the amount of steps it was randomly given. We said 1 to 3 steps. If it's on the edge, it will bounce. The asteroids will do this until it gets hit with the laser or until it touches your ship. So, repeat until touching laser cannon or touching edge. If on edge, bounce, and then move the number speed steps. So it's kind of cool. We then see what happens when the laser and the asteroid collide. If it's touching the laser cannon, and really might be better to say laser, first we increase the score by 1, and then we quickly change the asteroid to the next costume. Okay? And here's the costumes, folks. Right over here on our left. So there's the first, and so we can repeat this real quickly, and you can make it look like it explodes. This time, you're going to change these costumes very quickly, and that's how we give it that explosion. So you could, with the graphics, make your own asteroid and have your own fireball explosions occasionally. All right. So if the asteroid did not get hit with the laser and it's no longer hitting the sides, it's the only other option is that it hits the ship. So it broadcasts that back to the ship. So if it gets hit, if you go back to the player's sprite, when I receive a hit, I check to see how many lives I have, right? And if it receives it, so right now we're back. Make sure you go back and look at the player sprite, the spaceship sprite, okay? That's the player. Go back to the player sprite. If it receives a broadcast that's collided with the asteroid, it first checks to see if there's remaining lives. If so, change the hit boolean to true and decrease the lives by 1. It will also play sad sounding bit of music since you did lose a life, your ship. And just like with asteroids, it repeats a bunch of costumes so it looks like it explodes. So play spiral, that's the sound you've blown up. If you look at the repeat 7 times, next costume, it only waits for 1/10 of a second. So that the spaceship's going to blow up very quickly. Okay? So there it is. Big spaceship starts breaking down. The next piece of code makes the ship pause before returning to its initial position of 0, 0. All right, so it's going to blow up going to wait 2 seconds. It's not going to just pop right back up. One, it might run into the asteroid again, and two, it gives the player a minute to pause. You know, if you made it easy, you might give them more time or reset all the asteroids back so the player has a chance to shoot them, or you might give them less time and throw them right in there. It resets the hit boolean to 0 or false or not hit. So it says it doesn't hit anymore. So look, it goes to, so it waits 2 seconds, it goes to its location, it switches the costume back of the ship from exploded to looking like a ship, and it says set hit to 0, and then set forward speed to 0. All right, now we got about a little more than 20 minutes here. So let's go ahead and add some joystick controls to the game and make it feel like a real arcade. You did this last night. This should get you set up. Remember, your joystick's hooked up in such a way, and I know you've got this, but let's just review this. So this way, you've got the PDF. If you ever lose this, you're showing it to your friends. You got buddies messing around, and the joystick comes loose. You know how to hook it back up. This is the left pin. This is the right. This is up. This is down, and there's our common ground. And if I remember right, the wires are yellow, orange, red, brown, and we made them black or dark. They came with it. Okay? Each number pin by orienting your pie. Remember we talked about that, and here we are with the pie, and that's on the right side. This is the south side, this is the north side. So we can start counting down here. And in the way we've got our setup, you can set them up a little bit differently, but this is what we've done here. GPIO 5 and 6 or 2939 right here. That's, you know, that's the first one. That would be yellow. This would be orange, then red, then brown, then nothing here, and a ground. Okay. I think we're all set up, so I don't have to wait there, correct? Raise your hand if you have that already set up like that, ready to go. I believe we said earlier, so anybody that might have joined us late, we want to have that set up, so we can go ahead. All right, so raise your hand, get it set up so we can go on here. We'll just get a minute or two. We'll give you a chance to get it set up. So Ty, Home, Keyshawn, if you got it set up, Caden. Okay. Buttons don't care how they're wired. When your button goes in the ground, pin 20. So that would be like you could put one here and then pin 18 right here. So they can be left or right, but you will make sure you've got one pin going into here and shares this ground. And so we have that GPIO 18 in the ground there, GPIO 24 in the ground. So there's one pin in between the two of them. All right. We have done this. Go ahead real quick, run this program. You had it from yesterday, testing the GPIO where we made the cat. We put all this code under the cat sprite, and just make sure, and you can also do this if you just want to run your Space Invaders game. Just make sure on code that you know works, go ahead and run your joystick, make sure it's working. You don't want to spend 20 minutes working on your code thinking there's a problem with your code when indeed it was just something was loose or came undone. Okay? I'm putting everybody's hands down. Run your hands once you've got it going, where you know your little, you can use, this is a little test program I wrote just to make the cat move around, so I knew it was working. But you can also use your Space Invaders game. You got that working, I believe, last night, and we worked on it Monday, so try that. But run some code you know that works, so you know your hardware works. It's always a good habit to get into. Trust me, you don't want to sit there, and I know many of you guys do robotic competitions. That's a good habit for that too. Don't spend 20 minutes thinking it was something in your code when somebody left off the light sensor. So Jason, once you have it, Keyshawn, Ohm, or Trey, let us know. Raise your hands. Okay, good. All right then. Put your hands down. We'll go on to the next. You've got it working, so you know your hardware is working. So let's look at the code. Again, we're going to need to set our GPIO pins as inputs. You need to go, and we're going to do this. We're going to write this code. What sprite were we on when we saw earlier? Well, it was on this ship. So we're going to go to that ship, and we're going to need to turn the GPIO server on, and we're going to need to add some broadcast blocks, as I'm going to show you on the next slide. Go to this ship and try to see what broadcast you think you need to use. I'll give you 5 minutes to go ahead and start filling out the top. Right at the ship, after you click the green flag, there's a couple commands there. Add the commands you would need so you could turn on the GPIO so the Scratch will read it. I'll give you 4 or 5 minutes to do that yourself. And then I'll show you the code. And I have the PDF. And you have that and shows it in there. But let's see. It's really good if you start to learn, see how much can you do without us holding your hand to do it. Because once you can start doing where you understand it, now there's nothing limiting you and what you can do in making games. All right. Let's take a look together what we've got. When flag is clicked, turn GPIO server on, config 5, config 6, config 13, config 24. Kind of like we did last time. Raise your hand once you've got this bit of code on. GPIO server on is always, that line always has to be there. These other ones may or may not need to be. Raise your hand once you have this. It's Caden. All right, good, guys. Good job, Keyshawn. All right. And remember, you got to run this once, the GPIO server on, so the sense knows it's there. It's kind of one, when you go down, you're going to see we're going to need to do on the sensors. And for them to recognize that, you know, pin 15 and 6 and 13 and 24, what you're using, you need to run it once. Good. So I usually, once I get to this point, and actually I've got to make my buttons, but once I've done that, you know how you get this GPIO 5, 6, and 13? Those won't come up until you click this flag where it can broadcast it, and then it'll find it. Then you can use them. So right where it says left arrow key pressed, you put GPIO 5. You first bring down the green one, you make it equal to 0. It's like a pull-up resistor, I suppose. And that equals 0. And then you go to sensors and you pull in GPIO 5. And you drop in the sensor value there. So you're going to need to do your green, which is the math one, and then the blue sensor, and you're going to need to select GPIO 5. And that's going to replace left key, left arrow. Do the same thing with 6. That puts it up there. And this makes it go forward right here. Raise your hand once you've done that. And you can actually go ahead and run it and just keep using the space bar to shoot things. Pardon me, guys. All right. So how many, we got people raising their hand. Let me put everybody's hands down. If you've got it, so you now can use your joystick to turn your spaceship around and later on and drive it forward. How many you've got doing that? Raise your hand if you got it doing it. Well done. So is this kind of cool? You got games, you're putting the controllers in it, and you can make any kind of button or controller you want it to be. All right. Now, the time we have, let's go ahead to the next part. The sensor value can be found under the sensing tab, which is, we did this. Let me pull this over here, right? Whoops. And that's where we get that GPL 13, 24, 5, and 6, and we said that. All right. Remember what we just said. Run that green flag. Make sure you typed everything properly. That was when we run into trouble. You can also use the OR operator if the key left arrow is pressed or GPL server's value on. So if you really want to get spiffy, you could drop this whole thing on and make it an OR value. So you could either use left arrow or your joystick. So people could play whatever they want. You could also get a 2-player game going that way. And that is for firing as well. Okay? This is for the fire. When you got your firing, you got your moving speed. You've got where it says key spacebar pressed. You could put in GPIO sensor 24 equals this 0, and you can make that your button that's shooting. All right, and that's what we're doing here. So now see if you can get it so your button, pick the button you want to shoot and have it shoot. Remember though, if you have GPIO 24, another new button, you've got to put that, make it that as an input. These are all inputs. And we're not going to do this, but we could have set this up in a way too, where as your game's playing on your Raspberry Pi, we could have also turned on lights as different things as you shot different. If you shot a bullet with a button, you could have a light go on. Kind of behind what we do with we build a pinball game that way. All right. Putting everybody's hands down. Raise your hand. Once you've got it shooting, you feel pretty good about all that, okay? All right. Now let me ask, we've got about everybody getting that knocked out. Let me ask, we don't have a webinar next week. We don't have lab next week. It's the Thanksgiving holiday. Go and enjoy yourself. Now, feedback from you all. I'm going to put your hands on. Just listen. I want you to raise it so I can follow this. How many of you all are ready to do something? We've done enough. I think we've done enough programming. If you agree with that statement, we have done enough programming, then raise your hand. Okay. So about half the class says we've done enough programming. Okay. That's fair. Put your hands down. How many of you are interested in doing doing flight next? Raise your hand. I got one person, two, or a couple people really strongly want to do that. Okay. All right. How many of you people have the X-Plane disc from last year, from the Fly to Learn disc? Raise your hand if you have Fly to Learn. Okay, that was a disc we had last year where we did a flight simulator. Okay, I only have one of you. Probably going to run a survey. If that's the case, I'll get you discs and we're going to do Fly to Learn. It's an airplane simulator, and if there's enough time, you can actually design with it as well. Okay? How many people would be interested in doing that? You get to build the plane, you get to design it, you get to fly. It's a flight simulator, so you get to fly all over, change the wings, you'll see a difference in performance, those kinds of things. Okay, great. Put my hands down. How many of you have another suggestion you would like, or you would like to do in the spring? If you would, write me a question on that. As it stands now, we're going to build underwater robots, is our big deal. So, if you have suggestions on more things that you think you would want, let us know. Got a little bit of feedback. People are concerned what we did, same thing as last year, but I really went through the curriculum, guys, and we didn't do anything that you see this fall right now. We did a little bit of Scratch, just explaining it to get you started, review, and get everybody else up to speed, but we didn't do any of this. Heck, you couldn't do this with Scratch 3 weeks ago, 4 weeks ago. I mean, Scratch didn't have that capability. Something called Scratch GPIO, and it didn't work that well. Okay. So, hopefully everybody's got theirs going. Hopefully show it off in the holidays. It's impressive that you built this. And I'm going to talk to your teacher. And if it sounds like that we didn't do Fly to Learn, and remember, that was a disc, a DVD disc, with an airplane on it, a Cessna 172. How many people have that DVD? All right. We're going to make sure that you did. Okay? This might have been spring people that joined us. So we'll go ahead and include that. I will probably get that. I'm going to talk to Mr. Morrow and figure out a way to get it to him so we can get him way to you. Okay? All right, everybody. That's all I have. Does anybody have any questions? Okay. Thank you very much. Bye-bye. Bye-bye, all.